Let's go to page 767. And this is lesson 16-1. And the objective of this lesson is to learn and apply matrix terminologies. So over here, it says that a matrix, plural matrices, is a rectangular array of numbers enclosed by a bracket. So a matrix is numbers enclosed by a bracket. And so here are some examples of the matrices. Okay? Now, the numbers in the matrix are called elements. So this one has 6 elements. See, 1, 2, 3, 4, 5, 6, right? So this one has 2 elements. So each of these is an element. So these are 3 elements. Right? And the numbers horizontally are called the rows. So these are 3 rows. And the vertical is called columns. So there are 3 rows and 2 columns. This one has 2 rows and 3 columns. This one has 2 rows and 1 column. This one has 1 row and 3 columns. Okay? And the rows and columns are the dimensions of the matrix. So the first number is the rows, number of rows, and second number is number of columns. So like this one is 3 by 2. So 3 by 2. Okay? So, and this one is 2 by 3. So first number is number of rows, and second number is number of columns. So this would be 2 by 1. This would be 1 by 3. Okay? Okay, now, there are certain spatial matrices. Okay? The first one is a row matrix. A row matrix means it has only 1 row. Okay? And column matrix means it has only 1 column. And square matrix means you're going to have an equal number of rows and columns. So this would be 2 by 2. So you got 2 rows and 2 columns. And that's why it's called a square, because you got the rows and columns are the same. Okay? Now, over here, you usually use a capital letter to name the matrices. Okay? And so here's another spatial matrix. This is called a zero matrix. So zero matrix means every number, every element in the matrix is 0. And you use the O of 0 to name the zero matrix. So this is a 3 by 3 zero matrix. So 3 rows, 3 columns, right? 3 rows, 3 columns. Okay, now let's go to example 1. Example 1 says, write the zero matrix denoted by O 2 by 4 or 0 2 by 4. Okay? So this, again, the O stands for the zero matrix. And 2 by 4 means you're going to get 2 columns and 2 rows and 4 columns. So 2 rows, 4 columns. So that's how you write it. Okay? Okay. Now let's go to the next page, page 768. So page 768, it says 2 matrices are equal if and only if. When you say if and only if means forward and backward. Okay? It have the same dimensions and the elements in all corresponding positions are equal. So 2 matrices have to be equal if every corresponding numbers are equal. So like 3 equal to 3, 2 equal to 2, 5 over 5 equal to 1, negative 5 equal to negative 5, 0 equal to 0, 4 over 6 equal to 2 over 3. Okay? So every corresponding number has to be equal in order for it to be equal. Now these two are not equal because see over here, they don't match. See that? Because this does not equal to that, and this does not equal to that. So if they're not exactly the same, then they are not equal. Okay? Now this is very important principle because it will help you to solve some of the matrices. Okay? So like for example, example 2 is just find the value of each variable. So you can remember from this, right? In order to be equal, they have to match. So that means these two have to match. So you get x plus 5 equal to 2. See that? X plus 5 have to equal to 2. Negative 1 equal to negative 1, 4 equal to 4, and 6 have to equal to 3y. Okay? So again, 3y equal to 6. And from there, you can just use regular algebra. You minus 5 on both sides, so you got x equal to negative 3. You divide by 3 on both sides, you got y equal to 2. Okay? So matrix is fairly easy. Okay?